Hey, Nick Kennedy here, president and owner with the revolutionary FlexCNC machine tool. Hey, stay with me for a quick second. I'm gonna give you guys a quick tour. Is this something you see in your shop? Looks like a pretty big problem. Look, if you're gonna invest into a CNC machine, don't you care about bed size? What size parts are you gonna run? What size parts do you want to run? Maybe a better question, don't you care about flexibility? Well, come with me, check this out. This is the FlexCNC machine tool. Every machine tool we build, we give customers size and flexibility. This is our standard edition 20-foot long VMC. Don't be limited by a small machine bed. What we're building is the strongest, the longest, and the best priced CNC machine tool in the world. Experience massive action with us, don't settle, size matters. Click below to start making money for your shop. Hey, today we're gonna show you a pretty cool application, 20-foot long piece of tubing, set it up on the CNC, one op. We're gonna go through the top side of the part with the drill in this case, wrap it through and then drill through the bottom. No flipping of the part, just setting up on the machine once, hit and cycle start, super fast. Again, nothing's gonna be faster to process a job like this. You can see how long these things are, how heavy they are, how difficult they are gonna be to set up on any other machine. What we're gonna be running is 1 13/16 drill. About a little over 12 inches long because we have to go through both sides of the tube. Again, so we can do this all in one op. We don't have to flip the part. We don't have to do multiple ops. We're gonna set up on the bed and do it all in one setup. We're gonna hear a little bit of some squawking just because it's such a long drill, but it's the only thing we can use to get it all the way through the part in one setup. So that's it, running the 20-foot long tube. Got 9 holes, takes us about 9 minutes and 25 seconds. So I mean, that's super fast for such a big part, such a big hole, especially to go all the way through. Again, no better machine to run that on other than the FlexCNC G-Series, big gantry. Give us a call, 800-837-2503, and let us do a time analysis for you and show you how you can save a ton of machine time using the FlexCNC big bed gantry. What we're making are long bed, wide bed, vertical machining centers. The bottom line, they're custom bed machining centers for an affordable price to give shops an option to get into a big machining center to do big parts so they don't have to buy $1 million bridge mill or something that's just completely out of their budget. We're changing CNC machining with our capabilities and design. So if you need it, give us a call. We can build it and make it suit your needs. Hey, Nick Kennedy, FlexCNC. Hey, today we're doing a time analysis for a customer doing some dynamic machining in a block of aluminum. So what we did, we went and reached out to Kennametal to source a really nice end mill so we could really get our machine times down. And to explain this end mill a little bit, this is a 3/4 inch Kennametal Maxi Met. With this guy, we were able to take a 3/4 inch depth of cut, a 225 thou width of cut, and feed it around 90 inches a minute at 4,000 RPM on the FlexCNC. What we're going to show you is how using this tool versus your traditional 3/4 inch end mill, we're able to take our time from 10 minutes and 30 seconds down to 1 minute and 50 seconds. So using the Delta controller on the FlexCNC and high-speed tools, we're able to take a part like this and whittle it down in about 1 minute and 50 seconds. It's an awesome time analysis. The FlexCNC gives us a ton of machine bed to work with, and we'll be able to show you all those details and how setting up parts like this, we can set them up in stations and literally every minute, 50 seconds, make a part like this, nonstop. Using smart programming, great tools. Give us a call, 800-837-2503. Let us do a time analysis for you and show you what we're able to do with that FlexCNC and how we can help you make more money on your next job.
Size matters. Don't run your large parts on a small machine bed. Call 1-800-837-2503 and experience massive action.
What's up, everybody? This is Eddie from FlexArm, and we are coming at you live from our beautiful facility right here in Wapak, Ohio. And we have an amazing demo for you today. We're going to be doing some flow drilling. But before we get started, a couple of housekeeping items. On this side of the screen, you're going to notice there's a chat box, and we want this to be as interactive and as engaging an event as possible. So please make sure to put any comments or questions you may have in that section, and we'll actually pull them up in real time and answer those on the spot. So we appreciate that in advance. Also, down here, you're going to see a subscribe button. I want you to hit that subscribe button, hit that bell so we can get you those notifications on all the latest videos, and give us what my daughters would say is a huge thumbs up. We absolutely appreciate it. So as we get started, we have a very special demo where we're going to be doing some flow drilling today. So we brought the one, the only, the expert, my man, Mitch. Mitch, what's going on, dude?
Yeah, thanks, Eddie. We're going to demo today some flow drilling for you. We got some different styles of bits we're going to put in the machine today. We're going to show you some different styles of the standard bits, the flat style bits. We're going to have some larger sizes as well. So you got to get an overview of what's possible with the flow drill.
Right on. I'm excited, man. So as Aaron gets the application and everything started, tell us a little bit about what you do at Flowdrill.
Well, here we manage the office here in St. Louis, Missouri. We take care of all of Canada, U.S., and Mexico out of this office. We have offices in Europe as well. So we've been around for about 40 years. Strictly a sales office here. We do some R&D here as well, and we've been able to lately team up with you guys for some R&D, and then I think we'll touch on that a little bit later.
Beautiful, beautiful. Spoke like a true expert. So with this, while we got this live video going on, tell us really, for those who don't know, and much like myself who just learned kind of the last couple weeks, what is flow drilling?
Flow drilling, what we're doing is taking a tungsten carbide tool. We buy it in a raw blank form, and then we do some grinding our geometry onto it. It's a solid tungsten carbide. We introduce it to the material, and we form what we refer to as a bushing. an extruded portion on the bottom side that you see here. As that material softens, we advance the tool through it, and that's what forms, again, what we call the bushing. Typically, we get 3 times the original wall thickness that we begin with, and then that can be either tapped, it can be used as a bearing surface, we can use it as a braze connection. The Flowdrill itself can be used in most any malleable material. So today we're using mild steel. If you've got stainless steel applications, all we do is modify the parameter and we can use stainless steel. You can switch next to aluminum, copper, even some brass material. We can flow drill successfully. We offer any type of thread that you may need, be it a standard thread, a metric thread, NPT, BST, virtually any thread size that you need. We can make up a flow drill bit to do that thread size for you. Again, we can hit any dimensional change. If you just need say a press fit for something, we can meet that tolerances as well for you. We offer, again, 2 styles of flow drills. We have our standard that leaves what we call a collar. That's what is being demonstrated here. It leaves that upset material. We roll it over and it makes a neat little, almost like a washer, if you will, on that top side. The second style flow drill bit we offer is called a flat style. And what that does, we'll see here shortly, I believe, is we grind 2 cutting edges onto that bit. It comes down and will remove all that upflow material. So if you've got something you're trying to connect surface to surface, that would be the bit of choice. It's going to leave a nice spot face, flush top surface for you. Longevity of bits, typically in mild steel, we see 8,000 to 10,000 cycles. In stainless steel, that drops to 3,000 to 5,000. And then we've got some customers using aluminum where they don't change out for 75,000 cycles. So it just depends on your application, but we'll optimize it for you. There's Aaron holding that. I mean, that's a great looking result of a typical standard flow drill operation right there.
Now, Mitch, I ran this on some steel pipe with, like you were talking about with putting the collar on there. You know, what would be the advantage of putting the collar on there? Why would a customer want to leave that collar instead of shearing that collar off?
On round tubing, we typically always use the standard, just because if we try to use the flat style, we can only come down tangent to that top surface, and it leaves a little sharp edge on either side. So on round tubing, it's a standard method to use the standard tool. The advantages would be a little extra length in the overall thread length, so you get that additional little bit there of thread on the top surface. And the standard tool can be used on any shape of material. We can use it on the round, we can use it on square tubing, flat stock, rectangular, doesn't matter. The flat style bit, of course, would be used on square, flat, round, any place where there's a flat area where we can go in and flow drill and actually make a spot face. I think that's what Aaron's setting up now, is the flat style, and you'll see the differences here shortly between the 2. This bit's going to come down and actually spot face that top and leave it nice and flush.
Yeah, I'm getting the 2.5 inch square tube set up here. We're going to run that next flow drill to shear that collar off, and then I'll bring in a 1/2-13 tap, and we're going to tap these holes on this part here.
With the tapping operation, we utilize only roll form tappings. We don't use any cut taps. That keeps our process chipless start to finish. So if you got a long stretch of tubing where you're flow drilling holes, you're not going to have any debris inside that tube to clean out after you're all said and done. Cycle times are relatively short too. We typically land between the 3 to 6 second range on our cycle times. You'll be able to see that. I don't know how close we're going to get today with the video, but you can actually see those cycle times being relatively quick.
Hey, Mitch, while I'm getting this program pulled up here, something I know that you wanted to touch base on was the kind of industries that really utilize this process. Can you go ahead and touch base on that a little bit?
Yeah, absolutely. We got virtually the neat thing about the Flowdrill process and its applications is it fits anybody, anywhere. I mean, we're not subject to just one specific industry. We work with the automotive guys from the big three to their supply chain. We work with agricultural, making hay rakes, tractor cabs, mowers, all the attention to mowers and late. We're heavily into the ATV industry. They use a lot of that flow drilling for the fence. All ATV side-by-sides from the John Deere Gator to Polaris to Kawasaki, Honda. A lot of that industry is very, very strong with the flow drill at this point. But then we can switch to in the HVAC industry is huge for us. Eliminates the chips for those kind of customers, and they're not worried about contaminating and having warranty or return issues in their units. So all those industries, anywhere basically that there's a fastener, be it a rib nut, a cinch nut, any type of threaded and then a tapping operation. Now you can choose to use the roll form tap and then come back and thread that hole that Aaron's going to show you here momentarily, or you can choose to use a self-tapping screw. I'll refer back to the ATV industry and our customers in that industry. They choose to use self-tapping screws. So that's another option for you. I'll throw out there. I mean, you don't have to tap the hole. You can use the self-tapping screw if that better fits your application.
So I'm curious, Mitch, obviously you being the expert, what are we seeing? Like, what's happening right here? Can you give us a little bit of play-by-play?
Well, the flow drill makes contact. It's based on friction. So as that friction heats the material, it softens it, much acting like an annealing operation. And then as it softens that material, it allows it to gain top off. So that's causing a chip. That's the only time in the flow drill process that we will create a chip for you, is if we use this type of flow drill bit and it shaves that top upflow material away. All the other processes that we have, all the other bits will create no chips whatsoever.
Well, right on, man. Well, as Aaron is getting this part here and going towards the next situation, I'm curious. So you've probably seen a lot of applications in your day. So what's the coolest one that you've seen to date?
Oh boy, that's just on the spot. As far as size-wise, we did have a large size of a refrigeration company several years back that was trying all different sizes of NPT threads, large size holes. They make heat exchangers as well in this particular factory. And this was a 40-foot long copper tubing, had holes everywhere in it. They had a rotation of fourth axes that rotated the tube around, and we were punching anything from a 1/4-20 hole up to a 1 1/4 NPT in this particular size. So that was pretty impressive to see all those holes and all the configurations in that application.
No, for sure. I mean, flow drilling in itself, with everything that I've learned in the past couple of weeks doing my homework, never did I think that this was even a process. And a lot of individuals think that it's relatively a new type of technique, but I think you might be able to speak to how long this has actually been around.
Yeah, we came on the market in 1980, so we've been around a long, long time. 40 years anniversary this year. So, like I said, we started a European division, and then we brought it here into the United States in 1997. So a little less knowledge, a little less knowing about us over here, but we've been over 20 years strong here in the U.S.
Hey, Mitch, I'm finishing up this tapping cycle, and if you were to notice on the drilling cycle, I was using that paste, and here on the tap, I'm using the coolant. What kind of lubrications do you suggest using for these different tools?
We do have a proprietary We have a paste form for manual operations where limited number of holes where the operator has the time to apply it to the bit itself. In this case, where we're doing machining centers, we likely opt for a spray system, and that's a liquid lubricant. It's the same consistency, just in a liquid compared to the paste. And what it's designed to do is just create a barrier. We're not trying to cool the flow drill. It's a thermal drill operation, so we rely on that heat. But it does coat the bit. It prevents it from picking up particles of that parent metal, sticking to it, and that's what it's designed to do, just to prevent that buildup material from sticking on there. You see, that's a great example of the flat style, how nice and clean the top of there for your connection, and then there's no standoff in between the two pieces that way.
It looks like we've got a question. Fred Freeman, hey, thanks for commenting in. It looks like the question is, what's the smallest drill that you offer? So Mitch, I think you can take this one, man.
Yeah, I'll take this one. We can go down to basically a 1.2 millimeter is the smallest flow drill bit we produce. Screw size wise, roughly a 440 screw. So hopefully that'll answer your question. We go all the way up past 2-inch NPT. So if you've got a standard thread, you got a metric thread, NPT, you let us know what that size is, and we'll make a flow drill bit that will work for you.
There we go, right on. So I know we just got done going through the 1/2 inch, then we went to the steel tube, the 2.5 by 2.5, did a little bit of flow drilling as well as form tapping. Aaron, what's next for us in this demo?
Here I got another piece of the 2.5 inch by 2.5 inch, and we're gonna bring out the 31.4 millimeter flow drill that's gonna form a collar, kind of like that first one did on the pipe.
This is for a 1-inch NPT, fellas. So it's a little bit bigger hole. Just shows you some variances there. Like I said, we go all the way down to that 1.2 millimeter diameter, and this is a 31.4. So like I said, anything in between, we got you covered.
Might want to turn myself on there. So as he's getting this finalized, is there anything that we're going to see that's different when he goes into this steel tubing?
It's the same process. Thing that's going to vary is going to be the cycle time will be a little bit longer. We're pushing a lot more material down in there. So you're going to see that difference in cycle time. But as far as the process goes, it's irrelevant up to what size it is. It all follows the same operation as you see it going through the material. It heats the material, it softens the material, it allows that bit to advance on through. We're typically going to be achieving about 3 to 4 times the original wall thickness. It'll be a little greater in this situation here because we've got a larger diameter. We're folding more material down into that bushing, if you will, formation.
Now, Mitch, I know when we were testing these drills, we had talked about when we get into the bigger sizes, possibly taking a torch or something to preheat the tool. At what point do you need to, this drill is big enough that yes, I need to preheat it before, or no, it's good enough that I don't need to preheat before the operation?
We got a couple of different ways to do that, Aaron. What we can, on the smaller diameter bits, what we tend to do is the first hole that you make in a series, or the first hole of the day, is usually the worst hole that you're going to make because everything's cold. We need the bit to come up to temperature. We need the material to come up to temperature. So with that said, what we can do in a CNC environment, like you're running there, is elevate the RPM for those first few holes that you make. It's going to dump more heat into both the bit and the material. It's going to allow those first few holes to be successful. When we get above, an inch diameter, it's not going to hurt anything to preheat that with a small torch, just to get some heat built up in there. It takes a while. For the larger the bit diameter is, the longer it takes to get heat built up into it. So to short answer your question, probably I would be confident in saying above an inch diameter, we're gonna want to do a little bit of preheat. It also kind of depends on the wall thickness you're working with. we get into the larger diameters, we can of course go through thicker wall material, and that's going to generate more heat in itself. But the thinner walls that we're doing here today, I mean, it doesn't hurt a thing on a 1 inch or larger bit diameter to do a little preheat operation. With that said, I mean, you don't need to bring it to a cherry red. Just put a little bit of heat in there, and that'll help considerably. As you can see there, it's the same process as before. We're going to come down, form that collar. Basically, on the collar formations, we want that upflow material to hit the corner radius of the Flowdrill bit. We want it to curl back, come down, and just kiss the top of the material that we're working with. So you get a nice, clean, smooth, we call it a collar.
Yeah, I'm going to pull this part out here so we can get a good look at it.
Yeah, very, very nice. Man, that camera, whew, some solid flow drilling there, solid. Let's get a close-up on this part here.
There you go.
Oh,
Good
buddy.
job.
What are we seeing here, man?
That's a finished Flowdrill 31.4, ready to accept a 1 inch NPT thread. And you can see there, that material is 1/8 inch, if I'm not mistaken. And just rough guessing, we probably got a 1/2 inch of thread that we've generated in that connection for you. So just think of that, where before you were using a 1/2 inch thick piece to get enough thread engagement, you're down to an 1/8 inch material, and you have the same thread engagement. It's, cleaner, faster, stronger. It's just a savings all around for you.
I know that operation was pretty quick, so I'm going to go ahead and run another one here so we can get another good look at it.
There you go. Never complain about more flow drilling for sure. So, hey, Isaac, do we have any questions you want to pull up? No questions? Absolutely. So, hey, well, while we're getting set up, if anyone does have any questions either about the machine itself or flow drilling, please feel free to leave something in that comment section. We'll pull it up in real time and get your questions answered. So thank you so much.
I will say with the FlexCNC, we're seeing a lot more of our manifold customers where they have long lengths of pipe, where before they were using a standard machine. You have set up length of the table. I mean, they set it up in a FlexCNC, and you guys can put any length they need. So we got people with 10, 20-foot sections of pipe. Instead of doing multiple setups, they do one time, flow drill all the way from one end to the other, and they completed that part in one setup. It's really cool.
No, it just turns out beautiful. Look at that. Now, is that the finish that essentially that you're looking for every single time, Mitch?
Every single time. It'll be repeatable like that as long as your parameters are set. You got your height set correctly. I mean, there's no reason that the first hole is going to look the same as the 100th hole, as the 1000th hole, all the way up to, like I said, we achieve between 8,000 to 10,000 cycles typical per flow drill bit in mild steel. So good job, Aaron. That looks great.
There we go. The machine makes us look good. Just the flow drill, and it's awesome. So, no, and so really, that'll conclude our general demos. I know there were a lot of you that were really looking forward to us flow drilling the 66 millimeter or that 2 5/8 drill. So with that, as machinists yourselves or those who have worked with machinists, you all can understand that there's a lot of research and development that goes into it. And then also we're learning things every single day, regardless of the amount of experience that you may have in the field. And it's our job to be able to push this machine to its limit, and that's essentially what we've been doing. But we want to make sure that we can dial things in as the best way possible to ensure that we get you the best demos. So I guess to explain a little bit about what went on and how we went about things, Aaron, you want to talk about it a little bit, man?
Yeah, sure. So Eddie, I'm gonna have you hold this tool. This is the you got it?
Yeah, absolutely. It's a beast.
We ran here. How about I turn my mic on first? So this is the big drill that we ran here. And Isaac, I'm gonna have you pull up the screen here so everybody can see the program. And I wanted to touch base on this too. So we have a built-in can cycle for our flow drilling applications. And this, there we go. This G77 line that you're seeing right here is our Flowdrill can cycle. And how it works is the cycle is broken up into different depths that are run at different feed rates. And you know, as I'm saying that, Mitch, do you want to go ahead and explain a little bit on why we do that?
Yeah, we have different stages because we rely on that bit to develop heat correctly to allow that bit to advance. So basically our RPM will remain the same throughout the entire program, as you see, but we want different Z depth settings with corresponding feed rates. So as that bit starts out, we're relatively slow on the feed rate. We develop some heat, we get some heat generated in that material, it kind of softens and relaxes, allows that to advance a little further. So we're going to speed that feed rate up as it allows us to, and we want to, the goal is to get in and out as quickly as we can based on size and material, of course. But we want that 4-step cycle, 3-step cycle to allow us to advance. So it's a slow beginning, and then we gradually speed up as we travel through the material.
Now explain what we had to do with this big one. Now, I guess we didn't get a close-up of the other ones, but the other drills that we used in today's demonstration had a point, and this one has a blunt end. So we had to start with a just over 1.5 inch pre-drilled hole. Can you explain why we had to do that?
That was just this bit was used in an actual tube application previously, so we were limited in space. So what we had to do was blunt the end so we didn't hit the opposing wall. That's why that bit looks like it does. Typically it would come to a point just like the smaller tools that we produce. But this one did require a pilot hole. But when we get to this kind of size, generally speaking, we probably are going to use a pilot hole anyway. What that does is helps decrease the amount of load on the machine and against the part. Helps prevent some deflection. Like I said, just lessens that load against the bit of the machine.
Now I know this bit in particular you talked about was in a different application and a different industry, and it didn't end up making it into production. But when we brought it here in house, you know, essentially we were still R&Ding this thing, figuring out which feed rates were going to work best, which depths. And Isaac, I'm gonna have you run the B-roll of the first attempt with this big guy. And as you can see, as it's going down into the hole, you see the heat building up. And what ended up happening was we just weren't in the hole long enough to create enough heat, and the machine itself actually stalled out. You'll see the tool right there. It kind of got stuck on us. So, like I said, this was an R&D project. We were kind of all learning. There wasn't too many customers out there that are using this tool right now. There was a lot of communication between Mitch and I to try to figure out what worked best, and we had to adjust the feed rates. There was talk about adjusting the spindle speed to make sure we're creating enough heat, and changing the depths so we weren't trying to push too hard on that transition on the tool. So I made some adjustments to the program, and Isaac, if you want to run that next B-roll, we'll
But it's all R&D. I can't stress that enough. I mean, we went from a copper application to this steel, and then these guys have been willing to work with me to determine this data, and it just is going to allow us to go forward with larger tools. I mean, if we get an application that has even larger than this, now we've collected some data, we got some more knowledge, and man, I mean, we were so close to this happening. And it gets all the way down, starts to form the collar, almost there, and bam, we lost the shoulder. This particular tool, that shoulder was relatively thin to begin with. Normally it would be a little bit thicker than what it is. But again, I can't praise these guys enough for working with me to develop this data and allow me that knowledge to take back to our production where we can refine things in our R&D department. We're always looking for changes, for new ideas, new things, and pushing the envelope. And these guys have allowed that to happen. And like I said, everything doesn't turn out like we want it to, but the knowledge that we gained and the data that Aaron was able to gain for or get for us is invaluable at this point.
No, truly. So we appreciate you being creative and fun with us. We like to do some gnarly things over here at FlexArm. And it just, you see, I mean, I know it's we got a really high quality camera. We are so close there, man. So close, but it still looks great. And you know, if we're going to be doing some things with metal, it's nice to be able to try some new things. So we appreciate you teaming with us on that as well. So Isaac, do we have any questions we want to pull up here in that chat section? Well, no worries. Well, hey, I have some questions. So, Mr. Expert, I'd like you to tell us a little bit about the difference between forming and cutting the collar.
Well, the geometry of the cutting the collar, what we're going to do is we remove all that upflow material. So we put a 5-degree cutting angle on all of our flow drill bits that have that formation that removes the upflow material. And if that's the example there, Eddie, of the flush style, I mean, you see it's a nice clean surface there. What that's made to do is for connecting other parts where you got surface to surface finish. The strength is virtually the same. You don't lose any strength between the flat style to the standard in most cases. I mean, but the standard one, like I said earlier, we use that on round tubing exclusively, but it can also be used on the one that Eddie has there in his hand. If you want that raised feature, it's certainly doable on square tubing, flat stock, any shape for that matter. But that's the main difference. The strength is the same. It's just an aesthetic thing or how your connection needs to be when you're all said and done.
Beautiful, beautiful. Well, man, that makes another amazing demo. So with that, I want to make sure that anybody who wants to get a hold of Flowdrill can and get some information. Mitch, how does someone get a hold of you and get more info?
You can go to www.flowdrill.com. You can call me at 636-548-8485, or you can reach me by email at mitch.ray, R-A-Y, @flowdrill.com. We'll answer any questions you guys have. We'll do sample pieces for you. We'll work with you any way we can.
Well, that's awesome. Well, as always, I know this isn't your first stream that you've done with us, and we greatly appreciate it. You're an absolute gangster and an expert, and we can't wait to have you next time. Thank every single one of you for joining us, for commenting, giving us that huge thumbs up. Make sure you subscribe and hit that bell so we can keep up with the notifications. Thank you so much. Aaron, do you have anything to add, my man?
No, I think, Mitch, I appreciate all the help that you've been giving me throughout this whole process. It's definitely been fun. I appreciate it.
So I thank you guys tremendously. So we'll continue on, and we'll have some more fun demos in the future, I'm sure.
Absolutely. Mitch, you are the man. And as for everybody else viewing on the live stream, make sure to join us next week. We'll be with our good friends Kia Sarah doing some milling. But until then, you stay awesome, stay flexing, and we will see you next time.